Okay. Hello. You should be able to hear me and see the desktop now. Does that seem okay?
Yep.
Okay. Whoops. Okay. I'm just setting up some things over here. Okay. I think I'm ready. Let's see. Oh yeah, everybody's here, I think. Okay. Oh, okay. The first thing to point out is that there's another programming assignment, third one. It's due it's due Monday the 28th, which is a week from Monday. Okay. So not this Monday, a week from Monday. And I'm not going to say much about it right now because we're going to start talking about strings and string methods. And this is a homework assignment using strings and string methods. So we'll come back to it in about an hour. Let's start talking about strings and string methods. I'll download the zip file, but then let me download it and unzip it. But then we'll go and start talking about strings. And then before the end of the class, we'll go back to the assignment and I'll show you what you need to think about. Okay. But right now it's a little too early to say anything about the assignment. Okay. So let's, okay. Now the reading assignment for today, okay, there's a new reading assignment. The last couple sections in this chapter 2 of this book. Okay. And also there's a couple more homework assignments that are for practice. So this page has got 6 more of these mixed up code problems involving strings that we're going to talk about today. So do these 6 mixed up code problems. And then this other page has a bunch of programming, where you write the code, and I ask you to do problems 2, 3, and 4, 3 of them. Okay, so do those 3 programming assignments, small programming assignments. And remember, I gave you a similar assignment last week for some mixed up code problems and problems that you write. If you have any questions about those, you should be doing these. They're real important. If they seem real easy, that's great. That means that you're really absorbing the material, and that's fine. So if they seem easy, fine. If you have trouble with them, then you should be asking questions. Okay, because they should be, you should be able to do these in about an hour or so. Those 4 problems should take you no more than an hour. Same up here. I would think these 3 should take an hour or so to do. Okay, no more than that. Yeah, you should have to think about them a little bit at least. They shouldn't be trivial unless you feel if you feel really, really, really comfortable with this stuff, you can probably do those 3 in 15, 20 minutes. Okay, but if you're stuck on them, you should ask questions, and we can clear up what's going wrong. Okay, all right. And if people ask me questions, then I get a sense of what's because if you ask me questions, that helps me figure out where maybe we need more explanation. Because usually, if I get questions. If I get a question from one person, I usually get the same question from 4 or 5. But that way, I start getting a sense of where people need help. So it helps me if you ask. It helps you and it helps me both. Helps the whole class if you ask questions. Okay. All right. So there's a new programming assignment, another reading assignment for next week, and then these practice problems. Okay, and these practice problems are about what we're talking about today. So these practice problems are on. Well, actually, these practice problems are on these string objects and methods, which we're going to finish today. Okay, and then which is what we're going to finish today. And then on Monday we'll do these. Okay, so these practice problems are about these methods, these sections here that we're about to finish. Okay, and then we'll talk a little bit more about turtles today also. These sections aren't about turtles, but we'll say a little bit more about turtles, because what we're really talking about are methods and objects. See, we're really talking about the concept of objects and the concept of methods. Those are the two real important ideas in programming. We're using turtles and strings as examples of objects and their methods. Okay, all right. So if you go back to the turtle stuff, the idea was that you create an object and give it a name, and then you call methods on that object. Remember, the object is a bunch of data. So when you call these methods, each method manipulates or changes the data in that object. Now, in the case of a turtle, you see the data because like part of the data is where the turtle is. So this changes the turtle's location data, but the program draws the turtle in that new location. So you think you're telling the turtle to move forward, but what you're really doing is telling the turtle to change his location data, and then the Java system draws the turtle in the location of his location data. So you're not really moving the turtle forward, you're really telling the turtle to change his data. Same here, you're telling the turtle to change his heading data. And it just so happens that the graphics system takes that data and draws it on the screen. So this doesn't really turn the turtle, it changes the data in the turtle, and the Java GUI, the graphical user interface, takes that data and draws it on the screen. So when you change the data in the turtle, you change the way the turtle looks on the screen. But the method, what it really does, it does not move the turtle, it changes the data in the turtle. And it's actually something that we're not showing you that moves the turtle. There's a lot more code that that you don't need to worry about at this point, but the actual moving of the turtle is done by the graphics system. The graphics system built into Java draws the turtle, and it's responsible for actually drawing it in a different place. Okay? Now, we have a couple ways of drawing pictures of this stuff. Okay, here was our picture of what we mean by turtle objects in memory and turtle variables that refer to the turtle objects. So Yertle's not a turtle. Yertle is a name for a turtle, and this turtle's got another name called Yertle4. So Yertle and Yertle4 are two names for the same turtle. So we have these arrows pointing at the turtle. And then there's another turtle over here who's got a name Yertle2. Okay, so we have to, one of the things important to remember is that variables are different from objects. Okay, we have variables and we have what we call object variables. These are variables that refer to objects. So these are object variables. That's a turtle variable. This guy's a turtle object. Okay, real important distinction: object variables and objects themselves. You can have a bunch of variables pointing at the same object. And you can even have an object with no variable pointing at it. It's a little bit harder to do that. Okay, it's a little bit harder to do that, but later on we'll see that it's actually possible for we have what we call an anonymous object, an object that doesn't have a name given to it. Okay, so you can have variables with no object, and you can have a variable that doesn't hold an arrow. You can have objects that don't have any arrows pointing to them, and you can have objects with multiple arrows pointing to them. So we can do almost any kind of combination we want, because the variable is a separate idea from the object. You can have a variable that doesn't point at anything. You can have an object that doesn't have anything pointing at it. You can have an object with multiple things pointing at it, multiple variables pointing at it. Okay? This is one kind of picture. Now, then another kind of picture is this picture of the object. What it's doing here is it's showing you the data in the object. So we think of the object as holding that data, the location of the turtle. What color is the turtle? Is the turtle's pen up or down? So when he moves, does he draw or not? If his pen is up, he doesn't draw when he moves. If the pen is down, he's drawing when he moves. Okay, is the pen up or down? What direction is the turtle heading in? These get stored in the turtle. And like I said a minute ago, when you call a function, you change this data. And like if you change XY, that the forward changes the XY, then the Java GUI system reads that data and draws the turtle on the screen for us. Okay? So the method changes this data, and then the Java GUI system updates the screen for us with using this new version of the data. maybe change the color of the, if you change that variable there, these are actually variables. These are variables inside of an object. If you change that variable there, the Java GUI system redraws the turtle with that new color. If you change those variables there, the Java GUI system redraws the turtle in a different place. If you change that variable there, the Java GUI system redraws the turtle pointing in a different direction. Okay, so we got two kinds of pictures. A picture of the object to think about, which holds the data, and a picture of the objects and the variables that refer to them. Okay. The book has another version of this picture of the turtle, this part of the picture here. The book has a little bit more elaborate version of that picture right there. This is in section 2.4. Okay. This is supposed to represent what a turtle is. The data, a lot of people refer to them as attributes. I usually just call them the data or the variables in the turtle. But the fancy word for the data in an object is its attributes. Yeah. So that's the fancy word. Now, every object, I didn't draw it over here because there's not enough room. But every one of these objects also holds a copy of every one of its methods. So here, what you really think of as sitting in a turtle is all this data. And notice that here, this drawing actually reminds you of like what kind of type it is. Like the X and Y, well, the position of the X and Y are actually ints. They count how many steps if you think of the origin as at the center of the world, there's a certain number of steps to the right, that's your X position, and a certain number of steps up or down, that's the Y position. It's an integer because it counts the number of steps. Okay. Heading, now this picture is kind of weird. It doesn't show the heading, even though the heading would be in that list. The heading would be a double because you want to have degrees like you want to be able to have a heading like 2.5 degrees. So the position is an int, but the heading would be a double. Okay. The color is something called a color object. A turtle can be given a name. Be careful, this name is not this name here. This name for the turtle is a variable. Inside the turtle, you can actually store a string that is a different name for the turtle. Notice that this turtle actually has two names over here. He's got two variables pointing at him, which we often call names for the turtle. But there's also the notion that a turtle can store inside of himself a string that holds a name for the turtle. Okay, so that's not the variable name, that's the turtle's internal name, which you could use if you want. So there's a string inside the turtle called name. There should be a method down here to change the name, but they didn't put that. There's more data up here than they show in this picture, and there's more methods down here than they show in this picture. So this is just, again, it's kind of like what we did here. We just sketched a few of the pieces of data that's in a turtle. Okay, so here they're sketching a few of the pieces of data in a turtle. But you think of the turtle as two things: a bunch of attributes and a bunch of methods. Each method changes some piece of data up here. Forward changes the X and Y location. Turn left would change the heading, which you didn't list up here. Pen up would change a Boolean that would control whether the pen is up or down, which they didn't show up here. Okay. Forward with a parameter is different than forward without a parameter. Forward without a parameter moves you forward 100 steps. Forward with a parameter lets you pick how many steps to move forward. Backwards just takes that number and makes it a negative number in forward. So going forward 5 pixels, or going backwards 5 pixels, is the same thing as going forward -5. So backward with that. Now, if you go backwards -5, it's the same thing as going forwards 5. They're just it's actually, they don't need both those methods. They could have just forwards and make you use positive and negative integers. But to make it easier for people to think, they give you both a forwards and a backwards method. So if you don't like negative numbers, you don't have to use negative numbers. You can use forwards when you want to go forwards, and you can use backwards when you want to go backwards. If you want to be really weird, you could use only backwards and use positive numbers when you want to go backwards and negative numbers when you want to go forwards. Most people don't do it that way. A lot of people only use forward and just use positive and negative numbers, but they give you two methods. And then turn, see, turn is double. So the variable that holds the heading, the angle, it holds the angle, that variable is a double, and they let you turn by any amount of degrees. Okay. You can also move the turtle to a specific location. Instead of moving the turtle forwards and backwards and turning it left and right, you can just tell the turtle to teleport itself to that location. Okay, so move to just instantaneously moves from wherever the turtle is to that coordinates there. So you can just move the turtle from one location to another. You can jump a turtle. Okay, you can set its color, and then you can actually change the size of the turtle. That was the width and height of the turtle picture. That's changing the turtle, the little turtle that's drawn on the screen. You can change the size of the turtle drawn on the screen. Okay, so this is another kind of a picture of a turtle. Now, in our memory diagram, you would have this picture repeated inside that turtle, because every turtle holds all that data. But nobody does that. Nobody's going to draw a memory diagram with all that stuff in every turtle. So usually when we draw a memory diagram, a lot of times we just draw a box with turtle and maybe one or two, or whatever attributes we're worried about in our program, we might put those attributes in the picture to help us think about it. Or some people just draw it as an empty box and just remember, oh, this box holds everything about the turtle. In this picture, what's really important is separating the turtle variables from the turtle objects. We'll see as we go along why we want these memory diagrams to help us keep track of the turtle variables and the turtle objects. Okay, so pictures are going to help. We're going to draw lots of pictures of memory diagrams, pictures of objects. The pictures help us think about this stuff. Okay. All right, now let's switch from turtle objects to string objects. Okay, so let's go to thinking about string objects. Okay, so there's this section on string objects. Okay, now here they've created a notice that here they've done kind of a funny thing. They've created a string variable and set it equal to null. That is what I showed you over here. I said that it's possible to have a turtle variable that doesn't point at any turtle. When you set an object variable to null, it doesn't point at anything. So right now they have a name for a string, but no string. What happens if you run this? Oh, they're slow again today. See, it printed null as if that was a string. And this is actually kind of confusing. Null is not a string. Okay, null is not a string. Like, let me show you that this is not a string. Suppose I take greeting and I do one of the methods you can call on a string is to uppercase. So I'm going to call a method on that string just like I called methods on turtles. That's supposed to take all the letters in the string and turn it uppercase. So you might think it would turn it into capital N, capital U, capital L, capital L. Okay, right? So run this. The program blew up. There is no string there. Null, even though it printed out like it looked like a string, this is not, notice there's no quotes around it. This is a special value that means that this thing doesn't point at anything. Okay, so this is, I mean, from the point of view, I think this is a weird way to have started their discussion of strings. This is actually a real subtle idea. So I think they're starting off with something confusing, but let's go through what they're saying real carefully. they're creating a variable. Actually, now let me move this. Oh, let's put it on the code lens. What code lens will show us a little bit better what's going on. No, it doesn't.
Professor, you misspelled two uppercase as TU instead of TO, I think.
Oh, I didn't even read the error message. Thanks. Thank you, because that was real stupid. I thought it was the right, I didn't even realize that the error message I'm getting wasn't the one I wanted. Okay, now run it. Okay. Oh, error. It didn't change it up here. Ah, hide the code lens. Now this guy's mixed up. Okay, I changed it here. I fixed it here. Now they're mixed up. Let me comment that back out. No. That's really weird. Let me switch this to the Java visualizer. I think their site is doing something real weird. Okay, see, now I'm getting better pictures. See, greeting holds this thing called null. Something's wrong with their website. Their website is not running this program correctly. I'm not sure what's gone wrong, but it's not running this program correctly. So go over here in the Java visualizer. So I've created a string and it holds this thing called null. Okay, now I'm about to execute two uppercase. You might think this is going to turn into capital N, capital U, capital L, but it won't. Instead, I get an error message, null pointer exception. The problem is two uppercase is a method on a string. There should be a string object over here that I'm calling two uppercase on. There's no object. See, null is in greeting. There's no object. This is a mistake. Now, this is a weird thing to do, just to give. Occasionally we do this in Java. We give an object variable the value null to mean it doesn't point at an object. And I told you could do that in this picture, but I didn't show you how to do it. You can put the word null in here and it replaces the arrow. Now let's change this code a little bit to make more. I really think they're actually starting off with a very bad example here. By starting off with null, they're starting off with a very tricky example. They shouldn't start off with a tricky example, but that's the way they did. And it even confused it confused their code lens somehow. Okay, so let's make it a little bit more normal, and then we'll go back to what the null does. Okay, so let me put in hello. There's a typical greeting. Let's see. Oh, I have to go to code edit. So a greeting would be a string like hello. Now notice that instead of the null, I actually have a string because the string has quotes around it. Null is not a string from Java's point of view because it doesn't have quotes around it. Okay, so it's a special value. We say that null is a special value. Okay, so I put quotes around string. Now visualize execution. Oh, I want to change one thing. Oh, visualize execution. Okay, now I still got another problem here. This is not the right picture. Over here, that's not the right picture. The Java visualizer defaults to drawing incorrect pictures over here. Go back to here. We have object variables and objects. The object variables point to the objects. Right now, we're talking about string objects and string object variables. That's a string object variable. That's a string object. The string should be over here under objects. Java Visualizer drew it over here. It should be under objects. I think this is a mistake on their part, but they let you fix it. If you go here and click on options and you click on this checkbox, it draws the picture the way we've been drawing other object pictures, with a object variable on the left and the objects on the right. So you have to click on the options little options button and check this checkbox that says show strings. Now the picture will change and it'll be what we want it to be. There's the object variable holding an arrow pointing to the object. So the string is under objects, the variables under, well, they say under frames. Okay, so the variables live in the frames and the objects live over here. Okay, when you learn about computer architecture and how computers really work, you'll see that these are separate sections of computer memory. This is a section of memory called the stack, and this is a section of computer memory called the heap. So later on, you'll give fancy names to this half of the picture and this half of the picture. They actually have very technical names, the stack and the heap. Okay, but for now, it's just important for us to know that the object variable lives on this half of the picture, the object lives on this half of the picture, and the equal sign is what says that this one should point to that one, which is what we did in these pictures here. Okay, all right, now I can do the next step. I can say to uppercase. Okay, well, I did to uppercase. Notice that I did it. See, to uppercase is about to work now, but nothing happened over here. Okay, what happened to the to uppercase? Okay, now here's a really weird thing. Let me draw a picture. I'm going to draw a memory diagram. I'm going to draw my own memory diagram to supplement the Java Visualizer's memory diagram, because strings are a little bit odd. Okay, so if I draw my own memory diagram for this code here, okay, I'm going to replace their memory diagram with my memory diagram. Okay, so I've got, that's too big. I've got a variable that's on the left. The variable is a string variable, and the name of the string is greeting. So the name of the variable is greeting. Okay, and it points at a string hello. So over here is going to be a string object. Okay, now what's in that string object? Remember, what's in it is the data. What's in it are the letters. I'll just draw. What's in it are H, E, L, L, O. Now, I'm actually, here's what I want to. I want to make it look like. It's not really a string. It's the letters. I'll just draw it this way, because it's just data sitting in the object. It's a string that we think of as HELLO. That string is made up of 5 letters. 1, 2, 3, 4, 5 letters. That's the data in this object. Okay, so that's the left hand of this line of code. We're doing line 5. All this stuff over here is line 5. Line 5 created the string variable called greeting. Line 5 created a string object that holds the letters HELLO. And then the equal sign says that there should be an arrow from here pointing to that guy. So I'll draw kind of a sloppy arrow here. Okay, all right, there's line 5. Okay, so I've drawn the memory diagram for line 5. At this point, I've pretty much drawn what they've drawn. Okay, not much, they didn't draw a box around the object, but there's the letters HELLO in there. Okay. Okay. Now, here's what's tricky. When I call the toString, now I just did line 5. That drew this picture. So I go forward, and now I'm about to do line 6. You would think that the toUpperCase method would go in that object and change the letters to capital H, capital E, capital L, capital L, capital O, which is very much like what the turtle methods did. When you call forward on that variable, it goes in there and changes the XY coordinates. When you call pen up in there, it goes up and changes this variable, okay, in the object. Strings don't work that way, okay? Strings don't work the way some objects work. There's 2 ways for objects to work. Some objects change what's inside of them and some don't. So here's what strings do. When you call toUpperCase, this object makes a copy of himself. He makes a copy of himself. And that copy is another string object. Okay. And it places in the new object what you want. Capital H, capital E, capital L, capital O. So in here is the capital H, capital E, capital L, capital L, capital O. Okay. All right. So that's what line 6 does. Okay. Now you get to line 7 and you print the greeting. Why do you print lowercase HELLO? So why do I print lowercase HELLO?
Can you repeat the question, Professor?
We've called toUpperCase. Now we print greeting. Why is it printing HELLO? What happened to the HELLO? They're all caps.
Oh, because in order for you to do that, you have to call the toUpperCase within the print statement. You could say greeting dot toUpperCase.
That would be
system.
Okay. That doesn't answer the question. That fixes the problem.
Okay.
So you're right. What you just said would be a fix of the problem. But
Okay.
Why is it? Explain to somebody why it printed lowercase HELLO. Because I called toUpperCase on greeting, then I printed greeting. Why do I still see lowercase HELLO?
Because it's not taking it in, like it's not taking the toUpperCase in. What you're doing is you're printing out the greeting from the string.
Right. See, this name is what's printed. That
Exactly.
name is still pointing at this object.
Exactly.
Now, what do I really want? I want really a name to this object. See, now I've got what I told you a minute ago, an anonymous object. I've got an object down here that has no name. I actually created an anonymous object. I mentioned a minute ago that you could have objects with no name pointing at them. And that's what I now have. I have, when I called toUpperCase on greeting, what toUpperCase does is return an anonymous object with the thing you want in it. It does not change the object that you were calling it on. It gives you a new object. Okay. Now,
so the best route will probably to be turn greetings .uppercase to a variable, or put greetings to uppercase in the system out print.
Okay, there's 2 ways to fix the problem. Okay, so let's go back to the code so we can fix it. Okay, here's one way to fix the problem. Go ahead and print that anonymous object at the moment it's created. So instead of instead of putting that there, put it there. That prints the anonymous object. Okay, right? That's one way to fix the problem. Can anybody see a second way to fix the problem? Now I've got an anonymous object and I want to print the anonymous object. I can print him directly. Can we see what might be another strategy for fixing the problem?
Could you like declare like the name of the string, like string greeting capital equals greeting dot to uppercase?
Yeah. So what I want to do is not leave him anonymous. Give him a new name. So I'll call it string greeting uppercase. Now what I'm doing is I'm capturing that anonymous object and storing him in a variable. And so down here, I could now print out that variable. So here's my other solution would be now to okay, let me clean this up a little bit. Okay, so
You also need to, the greeting UC, you need to put the R. You put 3 E's.
yeah, I misspelled it. Okay, so I want to print uppercase HELLO. Two strategies for making that what the wrong thing. Let me okay. Wrong. Doesn't work. Doesn't work the way we want. Okay. All right. That's the wrong one. You call, oh, thank you. How many E's? Yeah. Okay. So greeting is the name of that string. Printing, these two lines of code don't work the way we want. So here's the wrong way to do it. You call to uppercase on greeting and you print greeting. These two lines of code don't do what we want. Okay. Okay. Those two lines of code these two lines of code don't do what we want. You call to uppercase on greeting. What that really does is gives you back an anonymous object, which you kind of don't even know is there. And then you're printing out greeting, but you're still printing out this. Okay. One way to fix it is capture the anonymous object, capture a reference to it. So give it a name. So it's not anonymous anymore. Okay. Give it a name, then print the name. Another way is just to print the anonymous object. It's still anonymous, but you can just go ahead and print it right away. Essentially, you're allowed to use it right away, even though it doesn't have a name. Now, let's visualize these and we'll see that this one doesn't work, this one works, and this one works. Okay. Now, let's use their visualizer. Okay. Now, this is the one that's going to return an anonymous object, which the Java visualizer does not draw for you. It doesn't draw the anonymous object because it only draws objects that have names. Okay, so you go here and an anonymous object sitting over here, and we don't know it's there. And since there's no name for it, since there's no variable pointing at it, the visualizer doesn't draw it. On your hand, you're telling it to print greeting, and greeting's still that guy. See, he didn't change. Okay, so that didn't do what we want. Okay, now let's do this one. Now this creates the anonymous object, but then we create a new variable and give it a name. See, there's that what was the anonymous object, but we captured a reference to it. Okay, now we can print the reference, using the reference variable, and it points to that guy. So now we get the output we want. And then this one, they're still not going to draw the anonymous object for us in this picture. But in fact, print line is printing the anonymous object. What will happen is I'm going to click forward, and I just get the output. Nothing happens to the picture. Okay, so it's a little bit. I wish they kind of were able to draw the anonymous object and show you that they were using it. But you have to know that that's what they did. That greeting, the two uppercase returned an anonymous object with the changed data in it. The changed data is not in greeting. The changed data is in the copy of greeting that holds the changed data. Okay, and then println printed the anonymous object. Okay, all right. So when you call the two uppercase method, this is the picture. Okay, so I mean, I would see. What I could do here is okay, this is the method we called. On this object, see the object, remember the picture we saw a minute ago, the objects hold their data and their methods. So we called this method in this object, but it did not modify its data. It did something a little bit different. This method made a copy of this object down here and then stuffed uppercase versions of those letters in the copy. Okay. And then if you don't capture a reference to that somehow by either using an equal sign and giving it a name, or calling or doing something with it right away. Okay, here I did something right away with the anonymous object. Here I got I captured its an arrow to it in a variable. So if I do something to capture this anonymous object, you know, either by sticking it in a variable or doing something with it right away, if I don't, I just lose it. It goes away. Yeah, like up here, create the anonymous object, and then it just disappears because I didn't use it in any way. I didn't capture a reference to it. I didn't print it right away, so it just disappears on me. Okay? All right, so strings are like turtles and strings are not like turtles. They're like turtles in that you have object variables and objects themselves. So you have object variables and objects themselves. Object variables refer to the objects. The object variables refer to the objects. If I wanted to, I could create anonymous turtle objects too, but they don't create. Turtles don't create. They don't create their own anonymous objects. What turtles do is every time you call a method on a turtle, it changes itself. Turtles change themselves. Strings won't change themselves. Strings always give you back another object with the changed data in the other object. It's a bit of an odd design, but it turns out to be a real important design in Java. Java essentially has, you know, whenever you're writing, when you learn to write more sophisticated Java code, you have to always ask yourself, should my objects act like turtles or act like strings? Do I want my objects to change themselves, or do I want my objects to not change themselves but produce new objects with the changed data in them? That turns out to be a design decision that's fundamental to Java programming. What kind of, when you want to write your own objects, or even when you use somebody else's objects, you have to ask yourself which kind of object it is. You have to know when somebody says, I want you to use my objects in your code, you have to know which kind of object is it. Is it a turtle-like object that changes its data as you call methods on it? Or is it a string-like object that never changes its data as you call methods on it? No matter what you do, when you call a method on it, it always gives you back a copy with the changes in the copy. And the original object never changes. Okay, we have a fancy name for that. These are called immutable objects. Yeah, mutate is a word for change, and you put an IM in front of a word, and it's like putting not in front of the word. So these are immutable, and these are mutable. So objects in Java, some objects are mutable and some objects are immutable. Turtles are mutable objects, strings are immutable objects. And if you Google, you'll find that there's a whole Wikipedia page just about immutable objects. Okay? Yeah. And I don't think there's a Wikipedia page about mutable objects because that's the normal behavior. 90% of the time, your objects are like turtle objects. They're mutable. So this is the exception. Strings are a very important exception to the mutable objects. The vast majority of objects are mutable. When you call methods on them, they change themselves. Strings are probably the most famous example in Java of immutable objects. But as people are using immutable objects more and more, it's becoming a style of programming to do more and more programming using immutable objects. Okay. So that's one big important distinction right away, is this idea of there's turtle-like objects and then there's string-like objects. Okay. Now let's go back to the null thingy that they did in their example. They did that null thing, which was kind of weird. Okay, now let's go ahead and let me go down here. Okay, go back to edit the code. Okay, now let me kind of go down here, and I'm just going to create a string, greeting. I'm going to call it greeting2, and I'm going to set it equal to null. Okay, so I'm going to set this string variable to null. Okay, and then I'm going to do something like greeting2 dot to, whoops. Okay, so I'm going to call the to uppercase on greeting2. Okay, this line will blow up on me because there really is no object there. This is not an object. This creates a variable that doesn't point to an object. Just like I mentioned here a while ago, you can have objects with nothing pointing to them, like we've seen already by accident. You can have variables that don't point at any object, and that's what we're about to create now. We're about to create a variable that doesn't point at anything. So then when you try to call a method, there's no object there to receive the method call. So step through the code. Okay, we know we've talked about that part. Okay, now, okay, create greeting2. Okay, greeting2, it's a object variable, but it does not point at any object. There's nothing over here it's pointing to. So who's going to get the to uppercase method? No one. So I get a error. My program essentially blew up. If this was in the middle of a long program, this halts the program because it's an error. It's called an exception. It essentially halts a program in its tracks. For example, let me go back to the code. Let me create another variable. Okay, there's another greeting, and I could do okay. I'm never going to get to lines 18 and 19. My program blows up at line 16. So watch what happens when I go to the visualizer. The visualizer is just going to halt my program at line 16, and it won't even go to lines 18 and 19 because the error halts the program. Okay, see, no, go back. I'm about to do line 16. Line 16 is the one that's going to blow up the program. As soon as it gets to line 16, I lose the forward button and I get this error. My program's dead. It never goes to lines 18, 19. When Java, we say the problem's blew, we just, the program halted. It stopped running. Colloquially, we just say it blew up. Technically, what it is, it threw an exception. The proper phrase is the program threw an exception and it stopped. The program is halted. When a program does something wrong, the computer halts it. Okay? which is actually considered a good thing. What's a good thing and a bad thing. If you're trying to land an airplane and there's a bug in your code, you really don't want the program to halt while you're landing an airplane. But at the same time, you don't want programs to just keep running when something's known to be wrong. You know, it's not good. There should never be bugs in programs because there's no good thing to do. If you keep running a program when something has clearly gone wrong, that's not a good thing. But at the same time, halting a program can be dangerous. This is why programming can be difficult, because in a life and death situation like programs that land airplanes, it's extremely hard to know what to do when you detect an error in the program. And huge amounts of effort goes into solving that problem. What should you do if the program that's landing an airplane detects an error? And we know that the airplanes will sometimes crash. It's happened, you know, the Boeing knows this really well. You know, their code had an error in it and it just kept running and it crashed an airplane. You know, it did not do the right thing when an error was detected. And all programs have errors. There's never going to be bug-free code. So an airplane has to actually, the code in an airplane has to do the right thing, even when it finds it did the wrong thing, an error. And right now, our Java programs do a simple thing. They just halt when something goes wrong, like this, the null pointer exception. I tried to to uppercase something that isn't there. Doesn't make sense. I can't to uppercase a string that's not there. You know, null is not a string. You're not going to get back capital N, capital U, capital L, capital L. Okay, see, it's not a string. It's not over here where the string objects are. So I asked my program to do something wrong, to uppercase something that's not there. So my program halts when it gets to that place. Okay, and then as you learn more about programming, you learn about the various ways you could handle this that might be better. Okay, right now programs halt when they do something wrong. Okay, now I can fix that by, there's nothing wrong with doing that. I can just do this. I can now give greeting to a value. So I can create the variable holding null, but then if I want, I can just say greeting2 equals, I'll do this. I'll do it greeting. I'll let greeting2 be greeting, and then I'll change this one to two lowercase. Okay, just to switch things around. Okay. Okay. Now, this will create an anonymous object. It's lowercase, so we won't see it. Remember, we're back to the problem that two lowercase just creates an anonymous object. But at least what this shows you is that you can create an object variable with no object in it. There's an object variable with no object. There's nothing wrong with that. That's not a mistake. You just better fill it in before you go do anything with it. Okay. All right. Now, this greeting2 lowercase, it didn't do anything. Well, it did something, but it created an anonymous object, and then the anonymous object disappeared on us. So this one created an anonymous object and it just disappeared on us. Okay. And then now I'm about to create greeting3, and now greeting3 to uppercase created that anonymous object, but then I gave it a name. So I caught an arrow to that anonymous object. Okay. All right. Notice that we're playing games with code and pictures, and the code is hard to understand and the pictures are meant to make it easier to understand. The pictures help to understand what's going on in the code over here. Okay. You should think in terms of what these pictures look like when you write this kind of code. All right. Now, with turtles, we talked about all the different things you could do with turtles. What's stored in a turtle and what can you do with a turtle? For example, remember we had that picture. Here's a bunch of things a turtle holds and a bunch of things you can call on a turtle. That's not exclusive. That holds more than this and you can do more than that. Okay. What about string? What's in a string? What would be the equivalent here? Well, what's in a string is easy. It's just the letters of the string. There's nothing else in a string but the letters of the string. Okay. So a string only holds whatever, however many letters that the string holds. So the attributes of a string are the individual letters of the string. On the other hand, a string has a huge number of methods, a huge number of methods. And we're not going to use anywhere near all of them. Now, let's go to the homework assignment, and I'll show you something. Okay, I downloaded the zip file from the homework assignment. So here's the page for the homework assignment, and I went to the page for, and I downloaded the zip file already, and I unzipped it. And in this homework assignment is about string objects. It's a homework assignment where you have to write a little bit of code, solve a problem with string objects. So I put in here a couple documents that give you a list of methods that are in string that are useful. These aren't by any means all of them. Here's a slightly longer list. Okay. So here's an abbreviated list and a slightly longer list. Notice everything in this list is also in this list, but they try to explain to you what the methods do. So here's what we're going to do now. We'll just play with these methods. We're going to experiment now in the Java Visualizer with just calling some of these methods, because you'll need to solve a problem in the homework assignment by figuring out which of these methods will help you solve the problem you need to solve in the homework assignment. So let's go over here to the Java Visualizer and just start playing around with methods on strings. So we've got some string variables. We've actually got a number of string variables right now. We've got greeting, greeting uppercase, greeting 2, greeting 3, greeting 4. Okay. Scrunch this over. Here's some methods I can call. Let's play around with these and see if we can understand what they're saying, and then let's use examples of. Okay, here's an easy one. The length of a string tells you how many letters are in the string. So if you do greeting, okay, dot length. Okay, now if I just call that method, whoopsie. There's the name of the object. It points at a certain object in memory. That object is HELLO. Then it calls the length method on that object. The length method counts the number of letters and tells you how many it counted. But this is going to return 5. What happens to the 5 that this returns? If I run this, will I see the 5?
No,
Why? Where does it go?
it just becomes, like you said, an invisible like object. It
Yeah.
doesn't exactly have a variable.
It doesn't have, yes, it doesn't have a variable to hold it. Yeah, so it's another example. If I, okay, visualize it and let's verify that, you will not see the 5. Okay, see, I just did line 22. There's no 5 showing up because I got a value and I didn't put it anywhere. It was an anonymous value. Okay, so what do you do to capture anonymous values? What do you
Naming
do?
them,
Pardon me?
naming them, and having them so they can actually be stored.
Stored in so what's the word we use? You store values in
It's on the tip of my tongue.
algebra variable.
Variable.
Yeah. So we need to take the value that's being returned and we need to say int n equal greeting.length. Now we know it's going to be an integer number because it's counting letters. So I can't just say n equals greeting because I have to declare the variable. So I need to say int n equals greeting length. I have to capture the value in a variable. Now I'll see the 5. Okay, see, if I go back, okay, line 22, I'm about to do line 22. Line 22 will create the variable n, call length on greeting, get the return number, and put it in n. Okay? So length counts the number of letters in the string. Okay? Now, what else can we do? That was length. Here's an interesting one, char at. If I go over to my picture of here, these letters are given indexes. They're each given a number. So this letter is number 0. This letter is number 1. This letter is index 2. This letter is index 3. And this letter is index 4. Notice I start counting the indexes as 0. So each of these letters is got an index attached to it. The first one, second one, third one, fourth one, fifth one, but they're numbered 0, 1, 2, 3, 4. Char at index lets me ask, what's the third letter in the string? Okay, so let me do that over here. So let me do greeting dot char at. Now, I want the third letter in the string. Is that right?
No, 'cause it starts at 0, right?
Yeah, the third letter in the string, L, is index 2 because I started counting at 0. You're going to see this all the time. Programming languages count from 0, not from 1. So when you want, say, the third letter in the string, that's index 2. Okay, the third letter in the string is this first L, index 2. Actually, I would have got the same answer here because the fourth letter in the string is also an L. Okay. All right. So if I want to show you that, let me get the second letter in the string. Okay. The second letter in the string is E. Notice that's not the. This will not be the first letter in the string. The H. It'll be the second letter. Okay. Now I get this. Now, what's going to happen when I run this? What's going to happen? Get greeting dot get the char at, the char is short for character. Get the character at index 1. The character at index 1 is E. So it gets the E and does what with it?
Nothing really.
Nothing really. We're back to, if you don't capture the value in a variable, it just goes away. Okay, so I need to go back and store the return, the variable in a, and I need a char. This is a new kind of variable. I need a char variable. Okay, char is a variable that doesn't hold a string. It holds just one single letter. So Java has variables that only are allowed to hold one letter. You can't put two letters in here. You can only put one letter. Greeting char at gives me a single character. It gives me the character at that location. Now I got something to hold it in. So now I go back over here and I go. Okay, that's going to create the integer n and hold a number in it. Now this line is going to create a new variable C, and see it holds a character. Notice that there's single quotes, not double quotes. So see, the strings have double quotes around them. The characters have single quotes around them. Okay. All right. So char at lets me ask, what is the first, second, or third character in the string? Now, here's index of. It's like the complement of char at. Watch. Let me do this. I'm going to go to greeting. And I'm going to say, what's the index? Where in the string is what is the index of O? Now, I know the answer is 4 from my picture over here. The index of H is 0, the index of E is 1, the index of L is 2, L is 3, the index of LO is 4. Okay, so I'm going to ask for greeting what the index of O is. And now I've got the same issue as before. Where does the answer go?
Nowhere.
Nowhere. I need a variable to capture the answer in. So now the answer is an index, which is an integer. So I'll create an integer. I'll say int index equal greeting index of O. Okay, now over here, I'm about to create a variable called index, which holds the answer of what was the index in greeting of the letter O. Now, here's a real interesting thing. What's the index of X in hello?
-1,
Why?
because the letter X character does not exist in that string.
Okay, so if what here's a challenging question. If you ask me the index of a letter that's not actually in the string, what should I tell you? If I can't give, I'm not supposed to give you back a number. I'm supposed to give you a number, but the index doesn't exist for that letter. So Java came up with a kind of clever idea. We'll tell you -1. Why? What's the point of saying -1? Does anybody get the kit? Why did they say this is kind of clever? If this letter's not in the string, we'll tell you its index is -1.
Just to let people know something is missing.
Well, why -1? Why did they pick that?
It can't possibly be the index of
Right.
of a character that's in the string.
They picked a number that couldn't be a right answer. See, -1, the indices start at 0. So the indices are 0 and positive numbers. So now they could have given you back -2. That would have worked also. Any negative number would have worked. Why did they pick -1? The answer is a little bit dumb. Any negative number would have worked. Why did they pick -1? Not a deep answer.
Is it just because it's 1 less than 0?
Yeah, it's the first negative number. Why not just give instead of returning -42, which might have been funny, somebody might have thought, oh, the answer to the meaning of life, but negative. They chose -1 because it's just like the simplest negative number. It's just, they couldn't give you back anything else because anything else could be the right answer. So they had to give you something that couldn't be a right answer. And that would be any negative number, and they chose -1 because it's just in a sense you could say, oh, that's the simplest negative number, -1. Okay, so then you run this. This is actually not an uncommon trick. When you want to give back an answer, but the answer somehow has to say this is wrong, you try to give an answer that couldn't possibly be a right answer. So the index of has to be a positive number. So if you ask for the index of a letter that's not in the string, you give a negative number because that means it must be wrong. That means that way you know that letter isn't in the string. Okay, there's the -1. Okay, and that tells us, oh, X is not in hello. Okay, all right. Now notice that these methods that we're trying so far, none of them change the data in the string. None of these would want to change anything in the string. They were asking questions about what's in the string. How many letters are in the string? What is the letter in the position 1? Where in the string is X? Now, other methods want to change the string. So, for example, 2 lowercase and 2 uppercase would change the string. Now, we know that when you do that, you always return a second string. So anything over here that would change the string would do it by giving you back a new string. It never makes changes in the string. Now, if of these, char at doesn't change the string. It doesn't try. Char at returns information. Ends with tells you whether the string ends with that thing or not. So that just tells you yes or no. Index of tells you the location in the string, so it's not changing the string. Length doesn't want to change the string. starts with is just like ends with. It just tells you whether that's the text at the beginning of the string or not. For example, let's just try that. Let's play with starts with.
So for the index of, what if you put like L, since it's in there twice, would it say like both 2 and
Oh,
3?
good one. It'll give you the first appearance of.
Okay.
But then there, okay, let's go back here. Let me change this to greeting 3. Greeting 3 is a little bit more interesting. It's got a little bit more letters in it. Greeting 3 is the one that's hello there, okay? And let me ask for the index of E. That's interesting. Why?
Because there's 3 E's.
3 E's. Okay. I'm going to call this index 1. Okay. And let me show you. There's an interesting trick in Java. It's not in this list, but it's in the other list. See, there's index of, then there's last index of. Now here's what Java will do. This will index of finds the first occurrence of that letter. Last index of finds the last occurrence. What if you want the ones in between? There's no method that finds them. You have to kind of work hard at getting them. So Java will find the first E in hello there, and it'll find the last E in hello there. And if I really want to know about the E's in the middle, I have to work a lot harder to find them. There's no method that'll find the other E's. It'll find the first one. This one could have been called first index of, last index of, but they just called this one index of, but it's really first index of and last index of. So let me run this. Okay, index 1, okay, hello there, 0, 1. So E, the first E is index 1, 2, 3, 4, 5. 5 is the space. It's there. Spaces are there. That's index 5. 6, 7, 8 is the second E. 9, 10 is the last E. See, 10. So I can find the first one, and so index of always finds the first one. And I can find the last one, but if I want the ones in between, if I think there's an E somewhere between the first and the last one, I have to work harder to find them. Yeah, and as we play around, we'll start seeing how we solve those little problems. Essentially, what you have to do is you have to peel off the first. If you want to find the second E, you've got to remove somehow the first E from the string, so then you can go in and find the second one, which then becomes the first one. So if you want to find a second E in a string, you have to remove the first one you found so that you can go then look for the second one, which is now the new first one. Okay, so it's a little bit tricky. You have to shorten the string so you can look for more E's. But it'll find the first one and the last one for you automatically. Okay, so notice that the last index of is not in this list, but this other longer list I gave you has more in it. And it includes the last index of. Now the string, now this is still not the complete list. If you want the complete list, the Java language maintains a website where they document everything. So here is the documentation for string. Now it's hard to read, and over time we'll learn how to read it. Here is the methods that are in every string. And there's something like 100 of them. Okay, I haven't counted them, but there's something like 100 methods. Okay, so there's an awful lot of methods in a string. And we don't need the vast majority of these. So we're not going to learn to read this page. because it's a little bit hard to read and it's got a lot more information in it than we need. So if you want to try, if you're interested in trying to start digesting these pages, go ahead. But what I'll do is I'll give you summary pages. Like I copy this out of a textbook. It's a nice summary page. And this other one's even a shorter summary page. These are methods you make a lot of use of. This page is actually a pretty good, these are the methods you tend to use a lot. So this is a good summary here. The book that picked this list did a good job of picking the list of the methods that people use by far the most. This is kind of a bare bones list. Like everything in this list is in the other list. So this is a pretty bare bones set of methods. This is actually a very good. You might want to print that out and just keep it with you when you're doing homework 1, because these are the methods that we're going to be using pretty much the rest of the semester. These are the really useful string methods. And then if you go to Java's website, you can read about every string method. And most of these I've never used these things. And they add new ones every couple years. They'll add new things to this list. The list just keeps growing and growing and growing. Okay. So for our point of view, this is a good enough list to keep track of. Okay. And let's see. Let me just show you real quick your homework assignment. You're going to take a string. You're going to prompt the user to type in a string. You're going to take a string, take the first word and move it to the end of the string, and take the second word and capitalize it. So this will be your input string to your program. And you have to find the first word in it, move it to the end, and take what was the second word and make it a capital. Okay. And there's some more examples here. Okay. And so you're gonna have to figure out what string methods. Use a scanner to read in the string. You'll use a scan. Like here, we haven't prompted the user for strings. Our code in this page has just been we just point at strings. Okay. Your program will prompt the user with a scanner for a string, and then to whatever string they type in, so you prompt the user, enter a string, they type in a string, and then you take the first word, move it to the end, with a space there before the word. You don't just tack it on to the end of this. You have to put a space there. And then whatever was the second word, you have to capitalize it. That's your homework assignment. And you'll look through here to find methods that can help you do that. Okay, so we run over time. Anybody got any last minute question? Any questions about what's come up that anybody want to ask real quick before we quit? I'll put these pictures we drew up on the course website so you can you can see them in the video, but I'll put these pictures up there, and similarly this code that we typed in here. One thing I would encourage you to do is play around with these methods. Start off by writing your own code in the Java Visualizer, just like I've been doing here. Just create some variables and practice calling these methods, and let the Java Visualizer show you what they do. Do that. Make your own little homework assignment. Create your own little example code. Create some strings that you think are interesting and start calling these methods. Try all these methods. See if they give you an explanation here. They even give you a little example of how, they give you the name of the method and what it takes as input. They tell you what it returns. They give you an example of them using it, and they give you a verbal description of what it does. Create your own little test cases. Create your own little examples. Okay, that's a good place to start learning this stuff. Okay, so any last question about the examples we've done? Anything? Okay, I'll stop sharing and then we'll meet again on Monday. Okay, and if you do have questions, please write me. Look at the homework assignment, start thinking about it. It's due, like say, a week from Monday. And if you have any questions about it, please write and ask. Okay, see you on Monday. Goodbye. Have a nice weekend.
Thanks. You too.